Hello, friends. Grab your coffee, grab your cookie, and today, please keep both very far away from any cement kiln or electric furnace because we are talking about a filter material that lives where most fabrics simply give up: fiberglass filter media. If polyester is the workhorse, Nomex is the firefighter, and nylon is body armor, fiberglass is the heat shield. I am Michael Klepik, and for more than 15 years, I have been designing dust collection systems for cement kilns, power plants, carbon black reactors, and high-temperature industrial processes. Today I want to explain why fiberglass exists and why it must be handled with respect. What fiberglass filter media really is. Fiberglass filter media is made from very fine glass fibers, woven or felted into a high-temperature filtration fabric. Technically, first, normal continuous operating temperature is 500 degrees Fahrenheit. Second, the fibers are inorganic and do not burn. Third, the material maintains dimensional stability at extreme temperatures. Fourth, it provides excellent filtration efficiency for fine particulate. Fifth, it requires careful mechanical protection due to fiber brittleness. Fiberglass is not flexible like polyester. It is engineered for heat first, strength second. Where fiberglass filter bags are used. Fiberglass is selected only when temperatures are too high for most other fabrics. Typical applications include: first, cement kilns and clinker coolers. Second, high-temperature rotary dryers. Third, carbon black reactors. Fourth, coal and biomass-fired power plants. Fifth, electric furnaces and metallurgical exhaust. Sixth, incinerators and thermal oxidation systems. Seventh, high-temperature process vents with dry gas streams. If the airstream is extremely hot and dry, fiberglass becomes unavoidable. Why fiberglass performs so well at high temperatures? Fiberglass has unique thermal advantages. First, it does not melt or soften at typical industrial exhaust temperatures. Second, it resists thermal shrinkage and stretching. Third, it maintains filtration efficiency under constant heat load. Fourth, it survives where synthetic fibers degrade. Fifth, it handles continuous high-temperature operation without loss of structure. This is why fiberglass is often the last option standing in extreme heat applications. Chemical resistance and limitations. Fiberglass has strong chemical resistance, but with one very important exception. Fiberglass properties include: first, excellent resistance to most acids. Second, good performance in acidic flue gas environments. Third, strong resistance to oxidation at high temperature. Fourth, poor resistance to hydrofluoric acid. Fifth, degradation occurs rapidly when hydrofluoric acid is present. If hydrofluoric acid is in the gas stream, fiberglass must never be used. Behavior of fiberglass in airflow and filtration. Inside a dust collector, first, fiberglass forms a stable dust cake that improves efficiency. Second, airflow remains consistent at high temperature. Third, the material is less flexible than felted fabrics. Fourth, mechanical shock can damage fibers if not controlled. Fifth, gentle but effective cleaning is required to avoid fiber breakage. Fiberglass works best in well-engineered, carefully controlled systems. Which Torch Air systems use fiberglass media? Torch Air installs fiberglass filter bags in several high-temperature systems. Blizzard high-temperature kiln Baghouse, used for cement kilns and clinker processing. Blizzard Power Plant Edition, designed for boiler exhaust and flue gas filtration. Blizzard Carbon Black Series, engineered for reactor exhaust with extreme heat and fine particulate. Custom furnace exhaust collectors, built specifically for electric furnaces and thermal processes. Fiberglass is never used casually. It is always a deliberate engineering choice. OSHA and NFPA compliance fiberglass filter media supports compliance with: first, OSHA particulate exposure limits in high-temperature industries. Second, cement and power generation emission requirements. Third, NFPA guidelines for non-combustible particulate. Fourth, industrial furnace ventilation standards. Fifth, environmental regulations for high-temperature exhaust systems. Correct material selection is critical for compliance and safety. Dust collector system, design considerations. When I design a dust collection system around fiberglass media, I focus on thermal control and mechanical protection. First, differential pressure sensors rated for continuous high temperature. Second, gentle cleaning systems to avoid fiber damage. Third, high-temperature filter cages and support structures. Fourth, proper inlet diffusers to reduce direct particle impact. Fifth, insulated housings to maintain stable operating temperature. Sixth, automatic hopper discharge for hot, fine particulate. Seventh, strict chemical compatibility checks to exclude hydrofluoric acid. This is how fiberglass systems achieve long, reliable service life. Fiberglass filter media is the solution when nothing else can survive the heat. With a normal continuous operating temperature of 500 degrees Fahrenheit, excellent resistance to most acids, and reliable performance in extreme industrial environments, fiberglass remains essential for cement kilns, power plants, carbon black reactors, and electric furnaces. I am Michael Klepik. Protect your lungs, protect your equipment, and remember, when the process gets hot, fiberglass keeps its cool. See you in the next video.